Imagine standing at the very edge of everything you've ever known, staring into a place where even the concept of before doesn't exist. That's the mind-bending reality scientists face when they try to unravel what came before the Big Bang. For most of us, the Big Bang is already difficult enough to wrap our heads around. 13.8 billion years ago, all of space, time, matter, and energy exploded into existence, from a point smaller than a grain of sand. But here's where it gets stranger. What if the universe didn't actually start there? What if the Big Bang was just a transition, one phase in a much larger story that stretches beyond the limits of time itself? This is the kind of question that doesn't just challenge our understanding of physics, it forces us to rethink what it even means to exist. And it's the kind of mystery that keeps scientists awake at night, because every time they get close to an answer, reality pulls the rug out from under them. Now, why should you care about what happened before time began? Because this isn't just about the universe, it's about us. The atoms in your body, the laws that govern your life, even the possibility that other worlds might exist. All of it ties back to this impossible question. Was there really a nothing before everything? Can nothing even exist, or is it always bubbling with hidden activity waiting to explode into something new? Some theories suggest that our universe came from a quantum fluctuation, a tiny hiccup of energy that appeared out of nowhere and refused to disappear. Others propose that our cosmos is just one bubble in an infinite sea of universes, each with its own laws of physics, each just as real as ours. If that's true, then you reading these words might be just one version of yourself out of countless possibilities, all unfolding in parallel realities we'll never touch. And then there's the even wilder possibility that consciousness itself played a role in shaping the universe from the very beginning. Quantum mechanics tells us that reality exists as probabilities until something observes it. So, what observed the universe before life ever appeared? Could it be that awareness, some kind of fundamental consciousness, was there from the start, collapsing endless possibilities into the reality we now call home? If so, then the Big Bang wasn't just the beginning of matter and energy, but the first moment when the cosmos began to notice itself. This is where the mystery deepens. Some physicists argue that asking what came before the Big Bang is like asking what's north of the North Pole. A question that only seems logical until you realize the concept doesn't apply. Time itself may have been created in that fiery birth, meaning there was no before to speak of. Yet other models, like cyclic universes or colliding higher dimensional membranes, suggest that there was a reality before ours, and that another one will come after. That would mean the universe doesn't really have a beginning or an end. It just keeps transforming, the cosmic phoenix endlessly reborn from its own ashes. So, when we ask what came before the Big Bang, we're not just looking for a scientific answer. We're poking at the deepest wound in human understanding. Why is there something rather than nothing? Why are we here at all? And maybe most unsettling of all, what if nothing is impossible? What if existence is the default state, an eternal engine that never stops, spawning realities forever? That's the rabbit hole we're diving into. And by the end of this journey, you may never look at the universe or your place in it the same way again. At the very heart of modern cosmology lies a paradox so unsettling that even the greatest scientific minds struggle to explain it. How can everything we know, every galaxy, every atom, every law of physics, emerge from what appears to be nothing? Section 1 begins with the foundation, the so-called beginning, the Big Bang itself, because to understand what might have come before, we need to break down what we think we know about that singular moment. When we talk about the Big Bang, most people picture a colossal explosion, a fireball bursting into an empty void, but that image is deeply misleading. The Big Bang didn't happen in space, it created space. It didn't happen at a point in time, it created time. Before it, there was no stage for the drama of the cosmos to unfold, no ticking clock, no background canvas. It was the ultimate reset, the moment when the rules of physics themselves were written. Yet even with this profound understanding, questions linger. If time itself began with the Big Bang, how can we even discuss what happened before? Is before a concept that has any meaning at all in this context? Or are we trapped by the limits of human language and perception, trying to apply familiar terms to an event that shatters them completely? The first few instants of the Big Bang, known as the Planck epoch, represent a frontier beyond which our current science collapses into gibberish. In that unimaginably tiny slice of time, 1043 seconds after the beginning, the universe was so hot, so dense, and so unstable that the forces we now consider distinct, like gravity, electromagnetism, and the nuclear forces, were fused into one unified force. Our best mathematical descriptions, Einstein's general relativity and quantum mechanics, failed to coexist under these conditions. Relativity describes the smooth geometry of space and time, while quantum mechanics describes the jittery, uncertain world of particles and probabilities. Put them together at the Planck scale, and instead of harmony, we get nonsense, infinities, contradictions, and equations that refuse to make sense. This breakdown is not just a technical hiccup, it's a cosmic warning sign telling us that the true story of the beginning is hidden behind a wall we haven't yet broken through. Even in the smallest slivers of time after the Planck epoch, the universe was rewriting itself at a pace that defies imagination. Space didn't just expand, it inflated. In less than a trillionth of a trillionth of a trillionth of a second, the universe went from subatomic size to something large enough to contain the seeds of galaxies. Imagine a bubble appearing on the surface of water, but instead of floating gently upward, that bubble rapidly grows to engulf everything. Except here, there wasn't even a surface to begin with. The bubble created the surface, the pond, and everything that would ever exist. This process, known as cosmic inflation, remains one of the most astonishing revelations in physics because it not only explains why the universe is uniform and flat, but also hints that our universe may not be unique. If inflation can happen once, it can happen again and again, spawning endless bubbles of reality in a grand multiverse beyond our comprehension. But even this picture leaves us with a gnawing mystery. If inflation was the trigger that set our cosmos in motion, what triggered inflation itself? Was it a random quantum fluctuation, a ripple in the sea of nothingness that somehow refused to vanish? Was it the collision of higher dimensional objects in realms beyond our own? Or is our entire observable universe just a small part of a much larger, eternal process, one that has been creating and recreating realities forever? Scientists don't know, and that uncertainty is both thrilling and terrifying, because it means that the story of our origin is far from complete. This first section sets the stage for the deeper questions to come. By breaking down the Big Bang as not just an explosion but the birth of space and time themselves, we're forced to rethink the meaning of beginning. If time itself started at T0, then maybe asking what came before is meaningless. But the very existence of this paradox suggests otherwise, that there's something deeper hiding behind the curtain. And that is where the real mystery begins. If the Big Bang marks the fiery moment when everything we know burst into being, then Section 2 dives into a stranger truth. What we call nothing might never have been nothing at all. When most people imagine nothingness, they picture a void, an infinite black emptiness devoid of light, matter, or activity. But physics paints a very different picture, one that is far more active, bizarre, and unsettling. At the deepest level, empty space isn't truly empty. It hums with hidden energy and flickers with restless activity. Even in the absence of matter, what physicists call the quantum vacuum is alive with constant creation, and destruction. Particles known as virtual particles pop in and out of existence by borrowing energy from the vacuum itself, living for impossibly brief instants before annihilating each other and disappearing again. This invisible dance isn't just a mathematical curiosity, it's measurable, observable, and real. In fact, it's so real that scientists can detect it through phenomena like the Casimir effect, where two uncharged metal plates placed extremely close together in a vacuum are gently pushed together by the pressure of these restless quantum fields. Empty space literally pushes. That means that what looks like nothing is actually a seething, bubbling ocean of quantum energy, an arena so unstable that universes themselves might be born from its fluctuations. Now, here's where it gets truly mind-bending. If this quantum vacuum exists today, if it fills every inch of space around you right now, then why assume it wasn't present before the Big Bang? If these fluctuations can create fleeting pairs of particles, then why not something larger? Some physicists propose that our universe itself began as a quantum fluctuation in this restless sea. Normally, such fluctuations vanish almost immediately, like foam popping on the surface of boiling water. But in one extraordinary case, the fluctuation inflated instead of collapsing, growing faster than the speed of light until it became everything we see today. Imagine a soap bubble that appears spontaneously on a flat surface. Instead of disappearing, the bubble grows and grows until it becomes the entire surface itself. That's what the leading theory of cosmic inflation suggests happened at the birth of our universe. Our cosmos didn't emerge from nothing. It emerged from the false emptiness of the quantum vacuum, which refuses to ever be still. This concept raises a haunting possibility. If our universe could emerge from a fluctuation in quantum foam, why would it stop with just one? The mathematics suggests it wouldn't. It suggests an endless cascade of universes, each birthed by its own fluctuation, each expanding into its own cosmos with its own rules of physics. We live in one bubble, but others are out there, endlessly forming, growing and drifting away in a vast multiverse. This isn't just wild speculation. It's the natural implication of what quantum mechanics and inflation predict. And if it's true, then our universe is not special. It's just one tiny ripple in an infinite sea. But the mystery deepens. If nothing is always buzzing with hidden energy, then maybe true nothingness doesn't exist at all. Maybe what we think of as nothing is simply another kind of something we haven't yet learned to fully describe. Even the concept of absolute emptiness breaks down under quantum law because the uncertainty principle forbids it. Perfect stillness, perfect void, perfect nothing is impossible because fluctuations must always occur. That means that before the Big Bang, there may not have been a barren emptiness, but a fertile ground bubbling with infinite potential. This flips the entire question on its head. Instead of asking, how did something come from nothing, we may need to ask, why does nothing refuse to stay nothing? And that question may be even stranger than the one we started with. ChatGPT said, if the restless ocean of quantum fluctuations suggests that nothing may never truly exist, then Section 3 takes us into a territory even stranger. The possibility that our universe is just one of countless others, each bubbling into existence like froth on an infinite cosmic sea. This idea, known as the multiverse, has transformed from a fringe speculation into one of the most discussed possibilities in modern physics. It begins with the realization that if inflation, the rapid expansion that shaped our universe in its first fraction of a second, happened once, there's no reason it couldn't happen again and again. The mathematics of eternal inflation suggest that inflation doesn't stop everywhere at once. Instead, it continues in some regions of space while ending in others, creating endless pockets of universes separated by vast inflating voids. Imagine boiling water, where bubbles constantly form on the surface, expand and break free. Each bubble is its own universe, with its own laws of physics. Our universe is one of those bubbles, but the pot never stops boiling. Somewhere, new universes are forming right now, expanding into realities we can never reach. This vision is as exhilarating as it is unsettling, because it means our cosmos is not unique. The constants of nature we marvel at, gravity's delicate weakness, the fine-tuning of the strong nuclear force, the near-zero value of the cosmological constant, may not be special at all. They may simply be lottery results from the vast multiverse. Most universes would collapse in chaos or expand too quickly for galaxies to form. Most would be sterile wastelands where chemistry, complexity, and consciousness are impossible. But every so often, the dice roll in just the right way, producing universes like ours, where stars ignite, planets form, and beings arise who wonder how it all began. In this sense, our existence could be less a miracle and more a statistical inevitability in an infinite sea of possibilities. But if the multiverse exists, its implications stretch far beyond fine-tuning. In an infinite ensemble of universes, every possible outcome of reality must play out somewhere. There's a universe where the dinosaurs never went extinct. Another where the laws of physics allow faster-than-light travel. Another where you made a different choice this morning and your life is on a radically different path. In some parallel reality, there's a version of you reading these words with just one word changed. While in others, there may be versions of reality so alien that even our imagination collapses in the attempt to describe them. Infinity guarantees repetition, variation, and everything in between. This doesn't just stretch science, it stretches philosophy, identity, and meaning itself. If every version of reality exists, what makes this one significant? If you exist in countless variations, what does individuality even mean? And yet, there may be evidence, subtle whispers of other universes imprinted in the fabric of our sky. Some scientists suggest that if our bubble universe collided with another in the distant past, the scars might still be visible today as strange circular patterns in the cosmic microwave background, the faint afterglow of the Big Bang. But these findings are debated. The very idea that we could detect fingerprints of other universes is staggering. It transforms the multiverse from a thought experiment into a testable possibility. But the most haunting question is not whether the multiverse exists, but why. If universes endlessly bubble into existence, what drives the process? What lies beneath the cosmic sea that keeps producing new bubbles? Is it quantum fluctuations in some deeper field? Is it mathematics itself unfolding into infinite forms? Or is it something stranger, something we haven't even conceived of yet? The multiverse doesn't end the mystery, it multiplies it. Instead of answering what came before our universe, it suggests that the question may never stop. There was always another universe before, and there will always be another after, an infinite chain stretching beyond comprehension. But infinity, as seductive as it sounds, may be the ultimate trap, because it explains everything and nothing at the same time. If the multiverse already challenges the very limits of imagination, Section 4 pushes us into an even stranger frontier, the role of time itself. Our everyday experience tells us that time flows from past to future, a steady river carrying moments along in sequence. But when we try to follow that river back to its source, we find the water disappearing into mist. At the Big Bang, time as we know it didn't just begin. It may have been created. This realization shatters the very language we use to ask questions. To wonder what happened before the Big Bang might be as meaningless as asking what's north of the North Pole. There is no before, because the very framework that allows before and after only came into existence with the Big Bang itself. This is one of the hardest truths to absorb, because it collides head-on with intuition. We can imagine empty space, we can imagine vast darkness, but to imagine no time at all, to picture a state where nothing happens because happening itself doesn't exist, forces us to abandon our mental anchors. It's not darkness waiting for light, it's not silence waiting for sound, it's the complete absence of waiting itself. Einstein's general relativity, our best description of gravity and space-time, works beautifully almost everywhere. It explains why planets orbit stars, why galaxies swirl in spirals, and even how light bends around massive objects. But when applied to the earliest instant of the universe, relativity breaks down. It predicts infinities, densities and temperatures so extreme that the equations simply stop making sense. This singularity at time zero isn't just a gap in knowledge, it's a flashing warning sign that our current theories are incomplete. Physics itself seems to hit a wall at the birth of time. To move beyond that wall, we need a new framework that unites relativity with quantum mechanics, the strange rules governing the smallest scales of reality. But without that ultimate theory of quantum gravity, we're left peering at the boundary between existence and non-existence, unable to see clearly what lies beyond. Yet hints exist. In quantum mechanics, uncertainty rules everything. Particles don't have fixed positions until measured. Energy fluctuates constantly in so-called empty space. What if time itself obeys similar uncertainty? Instead of being an eternal backdrop, maybe time emerges from deeper processes we don't yet understand. Just as temperature emerges from the collective motion of atoms, time might emerge from correlations between quantum states. In this view, time is not fundamental but emergent, a secondary property that appears only once the universe is complex enough to support it. That would mean before the Big Bang is meaningless not because there was nothing, but because time had not yet emerged. Reality may have existed in some timeless state, a realm where all possibilities coexisted without sequence, until a phase transition crystallized time as part of the universe's fabric. This raises staggering possibilities. What if the universe was timeless potential before the Big Bang, a frozen canvas of possibilities waiting to unfold? What if time was ignited along with space, energy, and matter in that first explosive instant? And could time itself end one day, collapsing back into a state where no sequence exists? Such a fate would not be fire or ice, but something stranger, the extinguishing of duration itself, the end of the ticking clock. And here's where it gets even more provocative. Some physicists propose that time may not flow at all. In the block universe interpretation, past, present, and future all exist simultaneously. Your birth, your death, and every moment in between are equally real, carved into the four-dimensional block of space-time. What we experience as the flow of time might be nothing more than consciousness moving along this block, like a flashlight scanning across a frozen landscape. If that's true, then the Big Bang wasn't the beginning of everything. It was the beginning of our section of the block, one slice of a reality that may exist outside of time entirely. That possibility turns our entire notion of beginnings and endings inside out. Maybe there never was a before, maybe everything simply is, all at once, and the Big Bang is just our entrance into the story. If the mystery of time forces us to rethink what beginnings and endings even mean, Section 5 confronts us with another enigma that lurks in every corner of reality: the hidden architecture of space itself. Our ordinary senses tell us we live in a universe with 3 dimensions of space and 1 of time. We move forward and backward, left and right, up and down, while the clock ticks forward. But what if this is only the surface, a projection of something deeper, something concealed, String theory, one of the most ambitious attempts to unify all the forces of nature, proposes that the fundamental building blocks of reality aren't particles at all, but unimaginably tiny vibrating strings of energy. Each mode of vibration gives rise to a different particle, the same way different vibrations of a violin string produce different musical notes. This framework has the power to combine gravity, electromagnetism, and the nuclear forces into a single theory, but it comes with a shocking demand. For the mathematics to work, the universe must have more than the 4 dimensions we experience. In fact, it needs 10 or even 11 dimensions, most of them curled up so tightly that we can't perceive them. Think of a garden hose lying on the ground. From far away, it looks one-dimensional, just a line stretching across the grass. But zoom in close and you see it has a circular dimension wrapped around it, tiny and hidden until you approach. String theory suggests the universe is the same way. At every point in space, additional dimensions are folded in on themselves at scales so small we'll never see them directly. Yet these hidden dimensions may shape the deepest laws of physics, determining why gravity is so weak compared to other forces, or why particles have the properties they do. What we call reality might be the faint echo of a richer geometry we're blind to, a shadow of higher dimensional truths. Some versions of string theory propose that our entire universe is a 3-dimensional brain floating within a higher dimensional space. Picture a soap film stretched across a wireframe, delicate yet complete. Our universe is that film, but beyond it lies a vast higher dimensional realm. Other brains may float there too, parallel to ours, invisible and unreachable because we're trapped on our own slice of the cosmic stage. But if these brains exist, collisions between them could release unimaginable amounts of energy. Some physicists suggest that one such collision may have been the very event we call the Big Bang, not creation from nothing, but the impact of higher dimensional objects. That means our universe's birth wasn't an isolated miracle. It may be part of a larger cycle of brain collisions, a dance in higher space that occasionally sparks new universes into being. This perspective transforms how we think about before. If our Big Bang was triggered by brain interactions, then something existed prior, other brains, other dimensions, a deeper reality that doesn't depend on our 4-dimensional space-time. It also opens the door to haunting possibilities. If parallel brains are real, they may be unimaginably close, perhaps only millimeters away in a higher dimension, separated not by distance but by the fact that we cannot move in that direction. Entire universes could exist right beside us, invisible but as real as our own. We might live in a vast cosmic archipelago, with each brain a universe island in a higher dimensional ocean. The hidden dimensions also force us to reconsider what is truly fundamental. If strings vibrate in 10 or 11 dimensions, then everything we see, stars, planets, life itself, is the music of geometry far beyond our perception. Our reality is a song played on invisible strings, its harmonies determined by spaces we can't see. This is both humbling and exhilarating. It suggests that the true origin of our universe might not lie in a singular explosion, but in the shapes and folds of hidden dimensions, silent architects that guide everything we know. And if the unseen dimensions can spawn universes, then the question of what existed before the Big Bang might find its answer not in nothingness, but in geometry itself, eternal, silent, and incomprehensibly vast. If hidden dimensions stretch our imagination to the breaking point, Section 6 takes us even further, into the idea that our universe may not be the only one, but rather one bubble in a cosmic froth that never stops forming. This is the territory of eternal inflation, a theory that grows naturally out of the very process believed to have powered our Big Bang. Inflation describes a burst of faster-than-light expansion in the earliest instant, stretching a subatomic bubble of energy into the vast observable universe we inhabit. This solves puzzles, like why space appears flat and uniform, but it also carries with it an unavoidable consequence. Inflation doesn't stop everywhere at once. Instead, it ends locally, creating pocket universes like ours, while continuing in other regions. The result is a multiverse, an endless process of new universes bubbling into existence like foam on boiling water, each with its own physics, its own constants, and its own story. This picture changes the meaning of our existence. Our Big Bang wasn't the beginning of everything, but the local transition, where inflation ended and expansion slowed enough for galaxies, stars, and planets to form. Beyond our observable horizon, inflation may still be raging, endlessly spawning new bubbles, each one its own universe sealed off by ever-expanding space. The distances are so vast and the rate of expansion so fast that no light, no signal, no traveler could ever cross the void between universes. From our perspective, they are unreachable, yet mathematically inevitable. In some of those universes, physics might look nearly identical to ours. In others, gravity might be crushingly strong, chemistry impossible, or time itself might flow differently. Most of these universes would be sterile, but the sheer number means some would harbor complexity and perhaps even life. The implications are staggering. If the multiverse is real, then our finely tuned universe, the one where forces align perfectly to allow stars to shine and atoms to bind, may not be rare by design but inevitable by statistics. Out of infinite universes, some must support complexity, and we happen to live in one of them because we couldn't exist anywhere else. This line of reasoning is known as the anthropic principle, controversial because it shifts explanation from uniqueness to inevitability. It suggests we're not the lucky winners of cosmic lottery, but simply inhabitants of one of the few universes where observers can exist. Yet this doesn't diminish the wonder. If anything, it deepens it, because it implies an infinite sea of realities, each strange, each possible, each real in its own way. But eternal inflation raises deeper questions. If it has no beginning and no end, then the multiverse itself might be eternal. Did it exist before our Big Bang, continuing infinitely into the past? Or did it too have an origin in some deeper framework we can't yet grasp? And if the multiverse contains every possibility, then does every choice we make exist somewhere else, with parallel versions of ourselves walking other paths? These are not just philosophical musings. They emerge directly from the mathematics of inflation and quantum mechanics. The boundaries between science and speculation blur here, but the logic is hard to escape. Some theorists even suggest that collisions between universes might leave detectable scars. If our bubble ever brushed against another, the interaction could leave imprints in the cosmic microwave background, the afterglow of our Big Bang. Circular patterns or unusual asymmetries in that faint radiation might be whispers of other universes touching ours before drifting apart. Evidence remains inconclusive, but the mere possibility electrifies cosmology. It means the multiverse might not just be speculation, it could be testable. In this light, the question of what existed before the Big Bang becomes less about nothingness and more about context. Our Big Bang was not the beginning of everything, it was the beginning of our bubble, our chapter, our local expression of reality. Beyond us, inflation may still roar, endlessly spawning, endlessly expanding, endlessly creating. The multiverse is not just another theory, it is a vision of infinite existence, where every possible reality plays out somewhere. And if that's true, then the story of our cosmos is far from unique. It's one wave in an eternal ocean of universes, each born from the same quantum froth, each carrying its own mysteries into existence. If the multiverse invites us to imagine infinite realities bubbling into existence, Section 7 forces us to face the profound consequences of one of the strangest theories in physics, the holographic principle. It begins with black holes. those cosmic abysses where gravity crushes matter so completely that not even light can escape. For decades, physicists believed anything falling into a black hole was lost forever. But this created a paradox, because the laws of quantum mechanics say information can never truly be destroyed. The resolution, discovered through years of study, is that the information doesn't vanish. It gets smeared across the surface of the black hole's event horizon, encoded like data on a two-dimensional film. From this emerged the real idea that all the information in a three-dimensional region of space might actually be stored on its two-dimensional boundary. In other words, our entire universe might be a hologram. At first glance, this sounds like science fiction, but the mathematics and evidence supporting it are serious. Imagine a holographic sticker that looks three-dimensional but is really just a flat image, with patterns of light encoded in 2 dimensions. The holographic principle suggests reality itself could work the same way. Everything we see, galaxies, stars, people, might be projections from data inscribed on a distant cosmic boundary. If that's true, then what we experience as depth and space could be illusions of perspective, like the image on a hologram that seems to extend outward even though it's flat. The physics of black holes demand this, and when researchers applied the same principle to the entire universe, they realized it could resolve some of the biggest contradictions between quantum mechanics and general relativity. This idea reframes the Big Bang in a radical way. If the universe is holographic, then the moment we call the Big Bang wasn't the creation of space and time from nothing, but the moment when the information on a cosmic horizon began to project our reality. Before that, the boundary existed in some latent state, holding the data but not yet processing it into the living, breathing cosmos we inhabit. Our history, from the first atoms to your reading these words, could all be the unfolding projection of boundary information. The Big Bang would not be a singular eruption of matter, but the initialization of an information processing system at the foundation of reality. This forces us to confront a deeper question. If reality is a projection, who or what is the projector? Some physicists argue there doesn't need to be one. Information itself is fundamental, and projection is simply how it manifests. Others speculate that consciousness plays a role, that observation itself might be the mechanism transforming raw boundary data into experienced reality. That means the act of being aware might be inseparable from the creation of the universe itself. The holographic principle doesn't just suggest a new way of understanding space, it hints that mind and cosmos may be intertwined more intimately than we imagine. And the implications don't stop there. If everything we know is encoded on a boundary, then distance itself might not be fundamental. 2 points in space that seem far apart could be close on the boundary, connected by quantum entanglement. The apparent separation of objects may be an illusion, with all of reality knitted together by the underlying web of information. This helps explain quantum phenomena that seem impossible in a three-dimensional world, like particles influencing each other instantly across vast distances. What we perceive as spooky action at a distance might simply be the shadow of a deeper two-dimensional reality where everything is adjacent. If this vision is true, then asking what came before the Big Bang becomes a question about the state of the boundary. What was encoded there before the projection began? Was our universe just one of countless possible holograms waiting to be played? Did another projection exist before ours, with its own story, its own laws of physics, its own observers asking the same questions? The holographic principle suggests the raw information might be eternal, existing independently of the particular projections it spawns. Our universe, then, is one performance in an endless library of cosmic holograms, each one waiting for the conditions or perhaps the consciousness to bring it into being. In this view, the most astonishing possibility is that we are not separate from the projection but part of it. Our thoughts, our choices, our awareness, are all woven into the holographic code, playing a role in shaping how reality unfolds. The line between observer and observed blurs, and existence itself becomes a collaborative dance between information and perception. If the universe is a hologram, then its deepest secret may be that it is not out there, separate and objective, but within us, inseparably linked to the act of observation itself. And if that's true, then before the Big Bang wasn't emptiness, it was information, timeless and complete, waiting to blossom into the reality we now call home. If the holographic principle shakes our sense of reality by suggesting the universe might be a projection, Section 8 pushes us even deeper into disorientation by challenging the very idea of time itself. For most of human history, time has felt like the most fundamental aspect of existence, an arrow moving from past to present to future, carrying us along in its current. We build our lives around it, measure our moments by it, and assume it flows independently of us. But physics tells a different story. At its deepest levels, time may not exist at all. Instead, it could be an emergent property, a byproduct of more fundamental processes, or even an illusion created by consciousness. The idea that time might be unreal is one of the most unsettling yet profound insights modern science has to offer, and it reshapes how we think about what came before the Big Bang. Einstein's general relativity already blurred the distinction between time and space by weaving them together into space-time, a four-dimensional fabric that bends and stretches under the influence of mass and energy. In this framework, time is not absolute. It slows down near strong gravity and speeds up in weaker fields. The past, present, and future all exist simultaneously in what physicists call the block universe. In this view, your birth, your death, and everything in between are not unfolding along a flowing river, but are fixed within the space-time block, existing together as points on a map. You experience them in sequence only because your consciousness moves along one particular path. The arrow of time, so essential to human experience, might be nothing more than a perspective effect. Quantum mechanics pushes the strangeness further. At the quantum scale, particles can exist in superpositions of states, meaning they are in many possible conditions at once, until they are observed. Some interpretations suggest that until observation occurs, even the sequence of events is undefined. Particles can be entangled across time as well as space, creating correlations between past and future that defy our everyday logic. Experiments have shown particles seemingly influenced by future measurements, hinting that time may not be the one-way street we assume. If the quantum world is timeless at its core, then perhaps time itself only emerges when enough complexity builds to create observers who experience it. This raises a haunting possibility. Before the Big Bang, there may not have been a before at all. If time is emergent rather than fundamental, then asking what came before the Big Bang could be like asking what's north of the North Pole. There is no before because there is no timeline to measure. The Big Bang wasn't the start of time, it was the start of temporal experience, the threshold where timeless quantum reality became ordered enough for an arrow of time to appear. That means the universe didn't erupt into existence from nothing. It emerged from a timeless state where all possibilities existed simultaneously, waiting for consciousness to perceive them as sequential moments. Some physicists argue that time emerges from quantum entanglement. In this view, the direction we call past is simply the state of lower entanglement, and the future is the direction of higher entanglement. The present is just the ever-evolving boundary between them. This idea reframes the flow of time as the unfolding of correlations across the universe, not a fundamental ticking clock. It also suggests that in the most primal moment of the cosmos, the Planck epoch, just after the Big Bang, entanglement reached a critical level, and from that point onward, time as we know it became possible. Before that, The universe may have been timeless, a quantum soup where earlier and later had no meaning. The implications reach far beyond physics. If time is emergent, then the ultimate fate of the universe might depend on consciousness itself. Our perception of time could be the result of our brains integrating information in specific ways, creating the experience of past, present, and future. Different forms of consciousness, alien, artificial or otherwise, might experience time differently or not at all. An advanced intelligence might learn to manipulate its perception of time, slowing it, speeding it, or even stepping outside of it entirely. If this is possible, then time may be less of a cage and more of a construct, one that can be shaped, transcended, or dissolved. Seen this way, the question of what existed before the Big Bang dissolves into something stranger. There was no before, because there was no time to measure it. The Big Bang was the transition from timelessness to temporality, from pure possibility to ordered experience. It was the moment when the eternal static of quantum reality was transformed into the melody of moments we call history. To ask what came before is to misunderstand the nature of time itself, which may be an illusion our minds generate as we move through information-rich patterns of reality. This perspective doesn't make the universe less mysterious, it makes it infinitely more so. If time is an illusion, then every moment of your life already exists. You are simultaneously a child, an adult, and whatever you will become, but your consciousness experiences those versions of you in sequence. And if time isn't fundamental, then perhaps what we call the Big Bang was not the beginning of everything, but simply the point where the illusion of time first emerged. In that case, the timeless realm that preceded it may still exist, not in the past, but alongside us, hidden beneath the flow of moments, waiting to be understood. We reach the end of this exploration. It becomes clear that the question of what existed before the Big Bang is less about finding a single neat answer and more about confronting the limits of human understanding itself. We started with the idea that 13.8 billion years ago, everything we know, time, space, energy, and matter, exploded into being from something smaller than a pinpoint. But the deeper we pushed into that question, the more reality unraveled. Each theory opened new possibilities. Each possibility raised new paradoxes, and every attempt to reach final certainty dissolved into even bigger mysteries. And yet, instead of closing doors, these revelations expand them, showing us that the universe may be far stranger, richer, and more alive with meaning than we ever imagined. What the Big Bang really represents may not be the beginning of everything, but rather a transformation, a phase shift, or even a moment of awareness where timeless possibility crystallized into ordered experience. One of the most striking lessons we uncover is that nothing might not exist at all, not in the absolute sense that we once imagined. When scientists probe empty space, they don't find a void, but a restless field of energy, flickering with virtual particles and potential. Even the vacuum refuses to be empty. At the quantum level, nothing is a storm of fluctuations, a sea of possibilities. This undermines our most basic intuition that something must have come from nothing. Instead, it suggests that existence is woven into the fabric of reality itself, inseparable from the laws of mathematics and physics that define it. If nothing cannot exist, then something has always existed in some form, whether as quantum foam, infinite mathematical structures, or raw potential awaiting the spark of observation. In this way, the Big Bang may not have been creation from nothing, but rather a shift from one form of being to another. Another theme that emerges is the unsettling idea that our universe is not unique. The mathematics of inflation, quantum mechanics, and string theory all point toward the existence of countless other universes, each with its own laws, each as real as ours. If that's true, then our cosmos is just one bubble in an eternal froth of universes, some sterile, some chaotic, and some perhaps hosting other forms of life and consciousness. This possibility reshapes the meaning of our existence. We are not the product of a singular cosmic accident, but one version among infinite variations. And yet, even in this vast sea of possibilities, we find ourselves in a universe that is fine-tuned for complexity, balance, and awareness. Whether by chance, by necessity, or by some deeper principle, our reality allows beings like us to ask these questions, to wonder at the mystery of beginnings and endings, and to try to make sense of the impossible. Perhaps the most profound possibility of all is that consciousness itself is not an afterthought of the cosmos, but a fundamental ingredient. Quantum mechanics suggests that observation collapses probabilities into reality, meaning awareness may play an active role in shaping the universe. If that's the case, then consciousness is not simply a product of physical processes, but something woven into the very fabric of existence. Before the Big Bang, there may have been not emptiness, but pure awareness, infinite potential waiting to observe itself into being. If so, then the universe is not just a collection of stars and galaxies, but the unfolding of consciousness, exploring its own possibilities, moment by moment. That would mean our existence is not random, but essential, not trivial, but central to the ongoing creation of reality itself. In the end, asking what came before the Big Bang is not about solving a puzzle with one correct answer. It's about realizing that the act of questioning itself is part of the story. Each time we push at the boundaries of knowledge, we reveal how much more there is to learn. Each paradox is not a dead end, but a doorway into deeper mysteries, and maybe that is the point. The universe may not hand us easy answers, because it isn't a machine to be explained. It is an infinite mystery to be experienced. Our role is not only to search for explanations, but also to marvel, to wonder, and to recognize that by asking these questions, we are participating in the very process of creation. So where does this leave us? It leaves us humbled, knowing that reality is far beyond what our current science can capture. It leaves us inspired, realizing that we may play a more active role in shaping the universe than we ever dared imagine. And it leaves us hopeful, because even if we never fully answer what came before the Big Bang, we know that the search itself connects us to something greater. We are not separate from the cosmos. We are the cosmos becoming aware of itself, asking questions about its own origin, daring to look into the void and discover that it isn't empty at all. The mystery will continue, the journey will never end, and maybe that is the ultimate truth. Existence itself is the story, and we are living it.